Now, prior to actually doing the calibration, the manual tells you to actually power it on and let it warm up for at least 30 minutes. The crystal's got to come up to working temperature. Now, I'm presuming that possibly you have to do that every time you actually use the unit to actually measure this, is allow it about 30 minutes to actually come up to temperature to get any kind of degree of accuracy out of this thing. So I'm ready now to actually do the calibration using the multimeter method. Now, this unit has been powered on for at least 30 minutes, and the manual actually tells you to do that just to allow the temperature of the crystal to come up to its optimum performance. So what I'm going to be doing is measuring pin 2 and pin 3 on IC6, which is this one down here, and I want to get the voltage down or up, I'm not sure yet, to 10 millivolts on those two pins there. So I'm going to be adjusting this and measuring those two pins at the same time. So I'm going to try and come around here and get it all in shot so you can actually see what I'm doing. So pin 2 is the positive and pin 3 is the negative, and hopefully you can see there it's at 14.8 millivolts. So I'm going to start to turn this pot to try and bring that down to its 10 millivolts. So I'm going the wrong way, so I need to turn anti-clockwise. So it's taking quite a few turns to bring that voltage down. Almost there now. So as you can see, it's at 10 millivolts now on the multimeter, so I'm quite happy with that. But I was a little bit surprised how many turns you needed to put on that pot to actually bring the voltage down. So if you do get one of these and you're having to put say 5 or 6 turns in there to bring the voltage down, don't be surprised. So it's not quite as sensitive as I thought it was going to be, but at least we're at 10 millivolts now. Now, unfortunately, the footage of me calibrating this using the oscilloscope was corrupted, and I don't particularly want to open this up again because it is bang on. But what I will tell you is using the oscilloscope, there was next to no difference between calibrating it with the multimeter and the oscilloscope. I didn't actually have to turn the pot any more than what I already did with using the multimeter method to actually calibrate this. So if you haven't got an oscilloscope and you've just got a multimeter, I wouldn't worry too much about it. Now, as you can see, I've already got the software loaded onto my laptop here, and it is a pretty straightforward installation of the software and the driver. But if you're using a 64-bit version of Windows, you will have to get around the unsigned drivers issue, because the drivers for this are unsigned. And there are about 6 or 7 different ways to actually get around that. It's pretty simple if you Google it, but the easiest way is to hit the F8 key during boot and then select the unsigned drivers menu just to disable it for that particular boot time. The only problem with doing that is you have to remember to do that every time you boot your laptop to actually use this meter. Now, since I've actually loaded the software on the laptop, I haven't controlled the meter by using any of the switches on the front panel at all. It's completely controllable in the software menu here, and the software menu is a lot easier to use than the front panel. It really is a selling point of this little meter. I haven't touched any of the switches on the front there at all, and to be perfectly honest with you, if they did a cheaper version of this without the LCD screen, I would actually buy that rather than spending money for the LCD screen, because I'm finding that I'm just not using it at all. I'm just controlling it all through the software. It's a much better interface and it's a lot easier to use than the LCD screen and the switches on the front of the meter. Now, if you're going to purchase this meter and use it, there is a couple of essential accessories that you actually need to get, especially for the power meter side of it, and the most important is to get hold of an attenuator. This one is a 10 dB attenuator, and to be perfectly honest, I use this most of the time for these kind of frequencies, because these kind of frequencies aren't designed to be excessively powerful. And this one's off eBay, as I say, and I think it cost me around £10 free shipping. And I've got a smaller one here. This is a small inline attenuator. This is only 3 dB. And here I've got a more professional one. This is one that's made by a branded company, and I actually bought this second hand off eBay, and I think I paid around £60 for it. But it is a 15 dB attenuator up to 8.5 gigahertz. If you see an auction for something like this, sometimes you know, if you keep an eye on it, you can get a much more professional one quite cheap. And if there's not a lot of bidders on there, and you can sometimes drop on and get lucky, but you really need an attenuator if you're going to be using this power meter. Now, the reason you need an attenuator is because the meter itself, the power side of the meter, is only rated up to 24 dBm, and to be perfectly honest with you, I would not plug anything directly into the meter that's any more than 20 dBm, just to err on the side of caution. So if you've got a 10 dB attenuator, you put it in the line in between the meter and your source, and that will reduce the power from the signal side down by 10 dBm. So you can measure things that are a lot higher than 24 dBm with this meter, and then just factor the dBm in at the end, the reduction of the attenuator that you've just used, and you can measure a signal that's much higher than the meter is designed to do. And I would also use an attenuator if I'm testing something for the first time. Let's say I purchase a 5.8 gigahertz transmitter off eBay, and the seller says it's actually 18 dBm. What I would do is, for the first time actually measuring that, is use it with an attenuator, just to make sure that the seller is correct about its rating. And then when you've found out that it does actually work at, say, 18 dBi, then you can do without the attenuator. But if you're measuring something new for the first time, I would always err on the side of caution and use an attenuator in line with it. And also, you're going to need some lengths of coax with the different connectors on there, SMA and RP-SMA, so you can actually connect your device up to actually measure it. Now, one thing you've got to remember with this little power meter and frequency counter here, it's not a precise piece of measuring equipment. It's costing around £120 with all the options, but what it's going to do is give you a ballpark figure of the frequency and power output of some of your devices. It's not going to be a precise piece of measuring equipment, so we have to cut it some slack. But what I'm going to do now, I'm going to feed a signal from my signal generator here, just so we can see the difference between what the little frequency counter here is putting on the laptop to what is being output by my HP signal generator here. Now, my HP signal generator was actually calibrated 2 years ago, and although it's probably due for another calibration, for me, I'm not going to pay out for that yet. It is actually working pretty much spot on. So we'll see what actual figure comes up on the power meter here as opposed to the signal generator, and that'll give us a good idea how accurate this little frequency counter is. So I've got the signal generator outputting 2.436 gigahertz there, and the little frequency counter is pretty much spot on. It's 2.405, so that's not too far out at all, and I'm quite happy with that figure. But you have to remember that before you actually do any measurements with this, you do need to let it sit with it switched on to actually warm up for about 30 minutes, because if you don't, the actual accuracy of this meter is way out. You have to let that crystal warm up to before taking any measurements, a good 30 minutes before you do any testing. Now, another thing with this meter, another thing with this meter as well is I haven't opted for the Now another thing with this meter as well, there is a crystal upgrade for this meter that is slightly more accurate and also faster in its update times, and I am actually going to order that. I haven't ordered it yet, because if I turn the wheel on the signal generator too quickly to change the frequency, this can't actually keep up and it does crash. So that's one thing that I have noticed with this. If you keep changing the frequency too quickly, it can't keep up and it will crash. But to be perfectly honest with you, that's not too bad at all. So next, what I want to do, I want to test the power meter side of things, and what I've got here are a couple of reference output modules that a friend of mine made for me out of an old spectrum analyzer signal generator, and these give out a precise frequency of, this one's 2.46 gigahertz, but it gives out a precise power output of 0.225 milliwatts, and this one puts out 2.410 gigahertz, and again a precise milliwatt output of 0.225. Now I normally use these for calibration because they are so precise. They are like a precise voltage measurement for, say, a multimeter, to test how good a multimeter is or to recalibrate it. So these are actually spot on. So we'll hook these up and see if it actually puts out 0.225 milliwatts according to this little power meter. So I've got the reference hooked up, and with the reference I do have to actually leave it on to actually warm up for a good 10 minutes prior to actually connecting it, just like you need to warm the crystal up in this. You need to warm the crystal up in this reference the same way, and we're now actually getting 0.234 milliwatts, which is 9 milliwatts out, but to be honest with you, that's not too bad at all. Remember, I keep saying that this isn't a precise piece of measuring equipment. It only costs £120, so I'm quite happy with that. That's not too bad at all. And while we've got the reference warmed up, I've flicked back over to frequency again, and the frequency on the frequency meter is 2.414, and this reference is actually 2.4110. So again, it's not out by much. It's pretty good, that, so I'm quite happy again with this one. So let's warm the other reference up and we'll give that one a test. So I've got the second reference connected and I'm still in frequency mode here. The second reference puts out 2.460, and again you can see it's not too far out. It's only out by 7 digits. So again, I'm quite happy with the frequency counter on this. So the second reference then at milliwatts is actually measuring exactly the same as the previous one, so we're 9 digits out there. So again, it's pretty good. Something else that you need to remember to do with the software on here is actually select the frequency down below here. So I've selected 2 gigahertz because if you don't, it does give an incorrect reading up here, so you have to remember to actually change that at the bottom. It doesn't do that for you, but again, I'm pretty happy with that. So it's only 9 digits out. So next, what I've got here is a 5.8 gigahertz transmitter that you would normally find on a quadcopter setup, something like that. I did order 2 of these from China. This one is apparently 2000 milliwatts, and I ordered one that was legal to use in the UK. That's restricted down to 20 milliwatts. Now that one didn't actually turn up. I've just got this one, but the first time that I did test this, I did have an attenuator in the line, so I already know the output power of this. But as I said previously, if you're testing something for the first time, just use an attenuator just to protect your meter. So now that I've powered the little transmitter up, you can clearly see there that it's only outputting 1100 milliwatts, or hovering around that mark. It's nowhere near the 2000 milliwatts that the seller was claiming that this little transmitter outputted. So without a meter like this to actually measure it, you probably wouldn't know. You're probably blaming it on bad weather, buildings and poor antennas, but clearly this transmitter is only transmitting at half the power that the seller claimed it was. And another little test that you can do with a video transmitter when you've got a power meter like this is reduce the voltage down to the little transmitter and see if the output power drops any when you actually reduce the voltage, because remember, when you're flying, the voltage is constantly reducing down on your battery. So if it drops down too much, you don't want the output power to drop as well. So I've actually got it on 11.3 volts at the moment, so I'll slowly reduce that down and see if we see any significant power drop. So I've got that down to 7 volts at the moment, and it's still operating, and it's still putting its output power at just over 1,000 milliwatts there. So I suppose that's not too bad, and it's a little test you can do that you probably wouldn't be able to do without one of these meters. Now what I've actually got here is a really cheap antenna off eBay, and this really is bad. You'd probably be better off using it as a shoehorn than an antenna. But what I'm going to do is test the coax that comes with this antenna just to see how much loss this is. So what we can do is I'm going to cut it off from the antenna here and put an SMA connector on this side, and I'm going to feed in probably about 500 milliwatts to start off with. And what we can do is feed it in on this end, measure it from this end, and then we can actually get the calculator out and see how much loss we're getting over some cheap coax like this, because I have said in previous videos that this kind of stuff is no better than speaker wire. So I'm using the signal generator to generate a 2.4 gigahertz signal, and this time I've got it at 1 dB, and I've got a short length of LMR low loss coax coming into the meter here, and the meter is 0.955 milliwatts. So again, I'm really pleased how accurate this little meter is. So what I'm going to do then is remove the LMR coax here, and I'm going to replace it with this cheap coax. And because we've got the signal generated at 1 dB here, we can then see what's outputted to the actual meter, and then we can work out how lossy this coax is. So same setup then, but this time with the cheap and nasty coax that you normally get with a lot of the cheap antennas, and this time you can see the power output, which is 0.00007 of a milliwatt. So it's losing a lot of power over a distance with this being so lossy. And we can also turn it up slightly, and you can see starting to get a little bit better now at 3 dB, but even so it's extremely lossy, and we could actually get the calculator out and work out just how lossy this is, but that should be a visual representation so you can see how poor that is. And I do want to get some of this coax in, which I haven't got enough at the moment, and we'll actually test some of this coax and also the semi-rigid coax to see how they all compare against each other. So overall then, I'm extremely pleased with this little meter, and especially how well the software turned out to be. As I said, I'm just using the software all the time now with the laptop. I just haven't used this independently of the laptop. I really like the software. It's really easy to get to grips with and start using the little meter itself. And again, as I said, it's not a precision piece of test equipment, but it is pretty accurate, and it does give you a ballpark figure, so you know exactly what your transmitters are putting out, and other tests that you can do, you know it's putting out the correct frequency, and there's lots of little experiments that we can do with this. And I will in a future video get some different coaxes in, and we will give them a test like I did quick and dirty with that speaker wire that I just did, because you know, you just purchase these things off eBay. I mean, I do myself, and just take the seller's word for it, but you know, it's really nice to be able to test especially coax and just find out how lossy it really is. So I hope you found this video useful. I am especially impressed with this little power meter. We're starting to see quite a lot of little test equipment like this filtering down now that these kind of frequencies are becoming more of a wide stream hobby, rather than having to purchase second-hand expensive equipment that's probably 15 years old and still paying quite a few £100s for. Little things like this are starting to filter down now, and this particular one is pretty good, I think, for the money. So I hope this video helped you in possibly choosing something like this, whether you'd get any use out of it. I'm definitely surprised how well this actually performed. I'm really pleased with this. But yeah, if you've got any comments or questions, drop them below, and I'll do my best to answer them. If you enjoyed the video, please give it a thumbs up, and hopefully you'll join me on the next one.